Hello students, how are you? In my previous videos, I have explained about the preparations of alkanes. Now let us see the chemical properties of alkanes. What are alkanes? Alkanes are the saturated hydrocarbons. Because of their high saturation, they are highly inert. Generally, they do not give any chemical reactions under normal conditions. Because they are highly saturated molecules, that means they have all single bonds. So, they do not readily react with oxidizing agents or reducing agents or acids or alkalis. But under some special conditions, they give some substitution reactions. Substitution means in the hydrocarbons, hydrogens are substituted by any other groups like halogens or nitro group. Okay students, now let us see the halogenation reactions. Halogenation is a substitution reaction and it is a free radical substitution reaction. What are free radicals? Free radicals are single electron species. So, halogenation is a free radical substitution reaction. Okay. What are halogens? Halogens are 17th group elements: fluorine, chlorine, bromine and iodine. And astatine, the last element, is a radioactive substance. So, it will not react. It will not give normal chemical reactions. So, let us see the reactions of fluorine, chlorine, bromine and iodine with hydrocarbons, that is the alkanes. The reactivity order of the halogens is: fluorine is highly reactive and it is a highly exothermic reaction. It is uncontrollable exothermic reaction. So, next comes chlorine, bromine. Chlorine and bromine, the rates of these reactions, chlorination and bromination, occur with moderate speed. They can occur at room temperature in the presence of light. And iodination is a very slow reaction and it is also a reversible reaction. So, a slow reaction, endothermic reaction and reversible reaction. So, iodination is carried out in presence of any oxidizing agent like HiO3 or HNO3. Okay students. Now, these reactions are written like this. Methane, I have taken the first member of alkanes, methane. Methane on reaction with fluorine. I said the reaction of fluorine is highly exothermic and it occurs very fast. So, to slow down that reaction, it is carried out in darkness. Okay. So, it forms methyl fluoride with one molecule of HF and delta H is minus 431 kilojoules per mole. Delta H negative sign indicates that it is an highly exothermic reaction. Okay. And chlorination and bromination. Reaction of methane with chlorine and bromine occur in the presence of sunlight or UV light and it forms methyl chloride and methyl bromide with one molecule of HCl and HBr. And you can see the amount of energy released in the reaction is decreasing from top to bottom. In the chlorination, delta H value is minus 104 kilojoules per mole and in the bromination it is minus 33 kilojoules per mole. That means the reactivity order is decreasing from top to bottom. And when it comes to iodine, iodination is the reaction of iodine with alkanes, methane. Here we have taken methane. It forms CH3I and HI. HI is a reducing agent. It reduces the methyl iodide formed in the reaction to iodine again. So, to prevent that, the iodination is carried out in presence of HiO3. Okay students. So, and iodination is, you can see the sign of energy, it is positive. That means it is an endothermic reaction. The rate of reaction is decreasing from fluorine to iodine. It is a free radical substitution reaction, and among the alkanes, the tertiary carbon, the reactivity order of different carbon atoms. Tertiary carbon greater than secondary carbon, greater than primary carbon, greater than methyl radical. This is the reactivity order towards the halogenation. Okay, students? And the stability order of other free radicals is, aromatic free radicals is triphenyl carbonium ion, triphenyl free radical greater than diphenyl free radical greater than phenyl free radical greater than allyl free radical, CH2 CH double bond CH2. This is the reactivity order of other free radicals towards the halogenation. Okay, students? In this, if we use excess of halogen, what happens? If we take a methane molecule, a methane has 4 replaceable hydrogens. If we use excess of halogen, all these 4 hydrogens can be substituted by halogen molecules, but they will not occur at a time. They will occur in steps. The substitution of all the halogens occur in steps. Step by step, one of the hydrogen will be substituted by halogen. Now, in this, methane is reacted with one molecule of chlorine. It forms methyl chloride by the elimination of HCl. This methyl chloride reacts with another molecule of chlorine. It forms methylene dichloride. Methylene dichloride again reacts with another molecule of chlorine to form chloroform CHCl3, and this chloroform CHCl3 reacts again with another molecule of chlorine to form carbon tetrachloride. Now, you can see all the hydrogens are substituted by halogen molecules, and this is occurring in steps. All the hydrogens are not at a time substituted by halogens. The sum of the net reaction can be written as CH4 plus 4Cl2 gives CCl4 plus 4HCl. This is with the excess of halogen, all the hydrogens can be replaced by halogen molecules. This is another type of halogenation reaction with excess of halogen. With equal ratio of alkane and halogen, we have seen the reaction previously. One of the hydrogen is substituted by halogen to give alkyl halides. Another important reaction of alkanes is combustion. We know that alkanes are used as fuels. In our domestic cooking cylinders also, they will have different types of alkanes like propane, butane, isopropane, isobutane. Like alkanes are present in the liquid petroleum gas LPG cylinders. Only alkanes are present, okay, and they undergo combustion. What is combustion? Combustion is burning of any substance in presence of oxygen. Burning in presence of oxygen to form carbon dioxide and water vapor with the liberation of huge amount of energy. That is known as combustion. So, alkanes are combusted in presence of oxygen to form carbon dioxide and water vapor to get huge amount of energy. This is the combustion reaction of alkanes. Now, there are different types of alkanes, and how much amount of oxygen is utilized for the combustion of different types of alkanes. We have a general formula for that. It is CXHY. CXHY requires X plus Y by 4 oxygen to form X moles of carbon dioxide and Y by 2 moles of water with the liberation of energy. It's a very simple general formula. If you remember this, you can calculate. In the entrance examination, they will ask you how much amount of oxygen is required for the combustion of any acetylene or ethylene or ethane or butane, like that. If you know the formula of that hydrocarbon, you can easily calculate how much amount of oxygen is required for the combustion, or how much amount of carbon dioxide is released in the reaction, or how much amount of water vapor is released in the reaction. Okay, students? Now, for this equation, C2H6. C2H6 is ethane. Ethane on combustion, that is burning in presence of oxygen, forms carbon dioxide and water vapor. Now, what is X value for ethane? X is 2. 2 plus Y value is 6. 6 by 4. 2 plus 6 by 4 oxygen is required for the combustion of 1 mole of ethane, and it forms X CO2. X here is 2 and Y value is 6. 6 by 2 water vapor. Now, what is this? 2 plus 6 by 4. 2 plus 6 by 4 is 2, 4 2s are, 2 4s are, 2 2s are 4, 2 3s are 6, 2 plus 3 by 2 oxygen. That means 2 2s are 4, 7 by 2. 7 by 2 oxygen is required for the combustion of ethane C2H6 to give 2 moles of carbon dioxide and 3 moles of water vapor. Now, let us see whether the equation is balanced or not. How much amount of oxygen is present? 2 2s are 4 plus 3, 7 oxygen. It is 7 by 2 O2. 7 by 2 O2 is nothing but 7O. 7O. So, by using this equation, we can calculate the amount of oxygen required for the combustion, or the amount of carbon dioxide released in the reaction, or amount of water vapor formed in the reaction. And these reactions are combustion reactions which give huge amount of energy. Any hydrocarbon, alkanes or alkenes, alkynes also give this reaction. They will give huge amount of energy. Okay, students? The heats of combustion of different types of alkanes is this order. Now, before that, in the presence of less amount of oxygen, that is the incomplete combustion, what happens? Only hydrogen will get oxidized and carbon remains as carbon. This carbon is obtained as carbon black, which is used as printer ink. Okay, students, this is also an important objective question. These are the different hydrocarbons. Now, let us see what is the order of their heat of combustion values. Which kind of alkanes give more amount of energy and which kind of alkanes give less amount of energy. That is the order of heat of combustion values. What is heat of combustion? The amount of heat liberated by 1 mole of substance on combustion is known as heat of combustion. Now, the first one, methane, ethane and propane. Methane gives less amount of energy than ethane, which gives less than propane. That means with the increase in the number of carbon atoms, the amount of heat liberated also increases. Number of carbon atoms increases the amount of heat on combustion. And the second case is, it is N-butane and this is isobutane. This N-butane has 2 primary carbon atoms and isobutane has 3 primary carbon atoms. With the increase in the number of primary carbon atoms and primary hydrogens, the amount of heat liberated decreases, because to break the bond between primary carbon and the hydrogens attached to that primary carbon, it requires more amount of energy. So, with the increase in the number of primary carbon atoms, the amount of heat liberated decreases. And in the first case, there are 2 primary carbon atoms. The terminal carbon atoms are the primary carbon atoms, 2 primary carbon atoms and 6 primary hydrogens. And in the second case, 3 primary carbon atoms and 9 primary hydrogens. So, this gives less amount of energy than the N-butane. And in the third case, these are the cycloalkanes: cyclopropane, cyclobutane, cyclopentane and cyclohexane. In this, the number of carbon atoms is less in cyclopropane, but it gives more amount of heat of combustion. What is the reason? Because it is highly unstable, more strained rings. With the less number of carbon atoms in the cycloalkanes, more strain is developed. Strain means the instability. As the instability is more, it readily reacts. It readily reacts with oxygen to give huge amount of energy. So, more strain, more amount of heat of combustion. So, cyclopropane, cyclobutane, cyclopropane greater than cyclopropane, butane greater than cyclopentane greater than cyclohexane. Okay? The smaller rings will have more heats of combustion. These are very important for the objective questions for NEET and JEE examinations. Hope you find this video very useful. Please subscribe to my channel. I am going to upload more videos. Okay students, thank you.